All right, I think we're good. Ooh, all right, hey everyone. Today is going to be a little bit more of a fun and exciting stream. Today we're going to show off how we integrate our high-speed camera or a high-speed camera with our data recording platform IS8000 and our DL950 scope quarter. I think it'll be a little bit more relaxed and a little bit more enjoyable to watch. We're going to be breaking some things and watching that in slow-mo. So that'll be cool as always.
You want to introduce yourself while we're waiting for
myself.
a few people to join
Yep.
in?
My name's Christian Loris. I'm an application engineer. So I get to work on projects like this, customer support cases, and sometimes some field visits. Main goal of mine is to just support the customer and make sure that our products are working well for them. What about you?
I'm Courtney Turner. I'm also an application engineer, so getting to do cool things like this all the time. Like Christian said, customer support, technical support, anything anyone needs, we're here to answer your questions and have a little fun while doing it. So like Christian said, we got the DL, let me make sure you can see it, the DL950 over here, and the IS8000 software on the computer.
Yep. And then behind you, we have a Photron FASTCAM Mini AX. So that camera can integrate with our software.
Yep.
All right. See, I think we've given some time for people to filter in. I think we should kind of get going on explaining kind of what each pieces are and how they kind of go together.
Yep.
So Courtney, would you like to explain kind of what the DL950 is?
Yeah, sure. So the DL950 is our scope quarter product, and what that means is the scope quarter is a Yokogawa term, but it combines an oscilloscope with a data recorder. So with this device, you can actually record for really long periods of time, up to several days, a month, at high sampling rates. One of our cards actually goes up to 200 megasamples per second. It's a modular device, so it's kind of hard to turn. I can do a little bit. You can see it a little bit, but on the side over here, there's 8 slots for input modules, and we have about 20 input modules that can measure voltage, current, frequency, temperature, strain, and many other measurements. Right now, we've got a voltage going in, we've got current from a current clamp, and we'll explain a little bit more about that setup later, and then also acceleration sensor as well.
Yeah.
So Christian?
All right. Well, so now that we have the instrument, we have the software package to go with it. Now, this instrument or this software connects with our DL950s and some of our other instruments like our WT5000 power analyzer and our DLM5000 traditional oscilloscope. And what this can do is this can link up with all 3 of the devices and start data recording synchronously across all of them. So this really improves and quickens your data analysis, as well as doing traditional math and other sorts of analysis after the fact. Mm-hmm. So that's the purpose of this software. And what's unique about what this software can do is it can also integrate with video. And in this case, we're going to use this high-speed camera. And so what it does is it will pull the data from the camera and from the instrument at the same time and then record them simultaneously so that you have time correlated and synchronized data of both video and electronic signals.
Right, and it does that by this outputs a trigger that goes into here, and once that trigger happens, that's when it starts recording the data.
Yep.
Right? So.
Yep.
Cool.
So now that we did a bit of an explanation of what each piece is, how about we get kind of into how they're connected? So behind Courtney again, the camera is connected via a LAN connection into the computer. And then this DL950 is connected via either USB or a LAN connection as well. For today, we're using a USB connection. And then to finalize the synchronization, we need to connect the DL950 with the camera so that the camera captures when a trigger occurs on the instrument. So on the DL950 itself, it's sending out both a clock pulse and a trigger pulse. And so that is coming into the camera to let it know the record rate, so how fast to record in FPS, but also the trigger, so when to start the recording process. And show a picture of what that kind of looks like. I can share the screen. Ooh, let me see this. You guys should be seeing the screen now, and then I'll show kind of what I'm talking about here. Is on the side of the DL950 here, we have the clock and the ground signals. They come into your input 1 here on the back of the camera, and then the external trigger out, also comes into the back of the camera. So that gives you an idea of how these are integrating together and how they're being synchronized into the software. All right. And then once we're in the software, pull this up. This is our software, and we're connected now, and we'll show a process of getting connected in a second. But here we can control the device itself, what its sampling rate, time per division is, and then also the camera settings are here as well. So we can get an idea of what's going on and making sure that we're recording at the settings we want. All right. Well, that was the introduction. Do you have anything else you think we should highlight before we kind of get into it?
I don't think so. Yeah, this video that you're seeing over here is from the high-speed camera, so you can see it as it's happening in the software. So we'll get to kind of see live what we're doing. But yeah, we have a few different things that we're gonna break today, and so I think it's gonna be a fun time.
Yeah.
Yeah.
Well, and maybe this is something we'll mention what values are coming into the instrument itself. Yeah. So right here we have a breakout box, and the breakout box is just supplying the voltage and the current from the wall to a light bulb that we have. You can see, and right here we're measuring those values in our voltage, our current, and then our RMS value, which is a real-time math calculated channel, which is taking the RMS of this channel, and then this is the channel we're going to trigger on as the bulb breaks to see the capture in the video. And then right here we have an accelerometer. So what we can do is we can set up if we can navigate to this channel. What's cool about our modular platform is we can have this accelerometer module card, and what this allows you to do is to bias this accelerometer. So this is actually supplying a voltage to it so that it can react with the change in acceleration. And so a few of our different module cards have unique features. We have a CAN bus card as well that we're not going to get to show today, but it also is unique in that it can take a CAN signal and trend that data. So really we want to highlight the modularity and the flexibility of the DL950 and how it gets integrated into all these different components.
Yeah.
All right. Well, now that I think we've explained a bit of this, you kind of ready to do our first break?
Yeah, let's do it.
All right. So let's get this set up. I'm gonna pull this camera out, or pull the bulb off. Set this on the ground. We don't want to break another bulb like some people have.
Yeah, you know, we just need a little test beforehand, make sure it would break, right, Christian?
Yeah,
of course.
All right. Bring this accelerometer down here. Make sure it's kind of lined up with the. Ooh, can you?
Oh, let me move. Yeah, there it is.
Make sure we're giving good light to it, and then have this bulb. Now, for the reason that it appears dark is when you're capturing many frames a second of video, your shutter speed has to be very high, and now in the light needed to illuminate the object must also be brighter for the faster shutter speed. So in here we actually have plenty of lights, making it pretty toasty in here for a summer day, but we're good. We'll set this here. All right. Ooh, it's a little bit bright. So now we can
Very
kind of
bright.
see in the video the light bulb. So what we're going to do is we're going to take a handy dandy hammer we have here, and we're going to break the bulb. And so when we break the bulb, ideally, we'll see the RMS current drop, because we won't be supplying any more current. And as the current drops, we're going to be triggering on that drop and then initializing the camera to capture all that data. So let me make sure that we're all good to go with that. Look at these camera settings. Good. We're only going to be recording for about half a second because we're going to be taking about 1,000 frames of data. We'll confirm this, and then we should be good to go. All right, you ready?
Yeah, let's see the first break.
Let's-
Oh, don't forget your safety glasses. Safety
Oh,
first.
Safety first.
Yeah, let's put those on.
Yeah, remember this, and I'll put some gloves on too.
Move
Now
out
we're
of the
all
way of the light.
safe. Got the closed-toed shoes,
Yep.
some gloves, some eyewear.
Safety first, everyone.
I think we're ready. Ooh. Ooh. All right, so now we're recording. And
Here we go.
did it work?
It triggered. Yep.
Yes. Ooh.
Yeah.
Let me stop this now. All right.
Awesome.
And now, now it's time to bring the software and the video together.
Oh, you
It's
do
going to
that.
take a second.
I'm gonna clean up our mess a little bit.
Nice. It did break for sure. Let's see.
It did for sure break.
Here, I'll switch the camera. Here's the carnage, everybody. Got ourselves a broken light bulb. Make sure this is powered off. Whew. All right. How can we set this off to the side? All right. Now that the software has finished combining, let me open it up. Open up the new file. And during these kind of breaks in between breaking, cleaning, and looking at the data, if you guys have any questions or any comments you guys want to make, definitely leave them in the chat and we can read them and respond to them.
Or anything you want to see us break. If we can find
Yeah.
it, we'll just raid Christian's house.
Oh,
It'll be
boy.
fine.
All right. Let me again share this screen now. All right. So here we have the post analysis of it. So we've recorded. Now we have them time synchronized. You can see down here is our frames. We can toggle through our frames, and then over here is the waveform. So as we guessed, once we broke the bulb, the current dropped out, so our RMS value dropped out, and with our RMS value dropping out, that's what we triggered on, and we can see the combo of them. Courtney, you want to see the
Yeah.
first carnage?
Yeah, let's see it.
All right.
What are we looking at here?
So we're here. We're going a couple frames a second now, and we can see the bulb actually brightening, flickering with the AC signal it's getting. And then
Oh yeah.
break,
Boom.
and we can see here the current drop out as the connections are broken, We can see our first impact, the impact connected before the final signal of current dropped out, and then we can see the current finally dropping out here. And then we can see the shards of glass that Courtney just picked up fly everywhere.
Might be cleaning that up for a minute. So we're gonna find shards of glass for,
Yeah.
for a second here.
It's gonna be fun. Might need a vacuum or something.
All right, cool.
All right, well that was first in success. So we got some signals and we got some
You
high-speed capture.
want to set up for the next one?
Yeah, we can set up.
We can unplug all this stuff.
We can still look at all these shards fly. There's only a half a second, so we can still see. They're like almost like shooting stars over here
Oh, wow.
as they fly. Yeah, we are going to be finding that stuff all over the place now, aren't we?
Oh, yeah.
I can tell. Ooh. All right. Get these new signals on here. Look at this athletic position I took to break the bulb.
I see. Christian wanted to make sure that it broke, so he gave it his all.
I did give it a good whack. All right, so while we're still looking at this beautiful video, we're gonna start setting up the next setup for the next break.
Let's see, we got some plates over here. We've got a piggy bank, some glasses, a vase, and some other fun stuff. Leave us a comment. We can go in order. Tell us your favorite, what you want to see first.
Ooh.
Oh man, it's still going. Too.
Yeah, that's what I'm saying. Look, you can still see all the shards. They're still radiating out of the impact.
It's a good thing we had the safety glasses on.
Yeah.
So now Christian's just hooking up just an extra signal just to show that all of this data is time synchronized. So with the DL950, you can actually have up to 64 channels. Is that right? Am I saying that right? Yeah, 4 times 8 slots.
Yeah, that's 32.
32 channels.
32
Sorry,
channels.
I'm thinking about how you can synchronize 2 of them together. You can actually synchronize up to 5. But yeah, 32 channels of data all synchronized at the same time. So from multiple signal type inputs.
It's still exploding. That's funny. All right, so I think I'm good here, and then
Cool.
go back to the software, and this time I get to kind of show you guys the setup process that we go through when bringing these two devices together. Close this. No. All right. Minimize this. Close out of this IS8000 because we're going to start a new iteration to kind of go through the setup process. So, IS8000 right here. All right, so all I've done so far is I've opened up the IS8000 software, and we're going to select the DAC menu. Now, automatically, it's going to recognize the auto search through the USB to find the 950. But to connect to the camera, we're going to input the Ethernet, the IP address of it. And we're going to do a search. See, and then we're going to pull up the two devices. Make sure we're bringing both of these in. Next, we're going to go into our channel settings. So right here we have just a voltage sinusoidal signal coming in. And this channel 9 here, this is our accelerometer. Bring this to the next page and leave these save settings as they are. Give it a second to load up. All right, so now we're here, and what's new is that we have this video tab, and we can go through and look at the video settings. First, we're going to want to make sure that our 950 is in the right mode. So since we're working on a trigger, we want to set it to trigger. We don't need all that sample, so we're only going to set a record length for 1 megapoints. And we're going to bring this down to a 1 second time per division. We want to make sure that our trigger out is a pulse. The pulse width specifically for this setup needs to be a pulse width of 50 milliseconds. And then this external sample output, we want to set it to free run, and this pulse rate is where we configure how fast we want the data to be captured or how many frames per second there is. So the device itself is sending out a pulse signal of 5 hertz to 2 kilohertz. This is what we're going to do, and that transfers to 2,000 frames per second on the camera side. So we'll set that 2 kilohertz. So once we got those configured, we want to go into the sync settings on the camera. So that was under the video tab, then here's sync settings. See here we have the 2000 FPS. Our shutter speed is 1 divided by that. This is our resolution, and then here's our before trigger frames and after trigger frames. So we'll set this to 200 because there's not too much interesting things happening beforehand. And then we'll have 800 after the fact, so we can see all the explosion that'll happen. And then a total record rate of 1,000 frames. Below here is the actual recording time of, this is 0.5 seconds. So make sure these get applied. And then down here, we want to just confirm that these settings are correct, and it'll adjust your time per division and your trigger position for this camera setting. So now that we've set those up, the 950 set up, the camera should be set up. Now, all we're ready to do is to do the next braking.
Yeah, let's do it.
Let's see. Is there anything we want to break first specifically? What about a plate? Maybe start off. We have a couple plates.
Yeah, let's do a plate.
So we can see how that goes, and then move on from there. Oh, let me get the video over here too, so you guys can see what's going on. Ooh, you guys, yep, it's working. Let's see. All right, so now that we're all set, we got the video, we have the signals coming, or the DAC monitor ready. We want to press record to start basically the analysis window. So once it's recording, it's going to be waiting for a trigger on the DL950 and also for the data on the camera, and that allows it. So we want to press record to basically get ready for everything, so that the camera starts knowing it needs to start recording. Even though it won't save all of its frames, it knows it needs to save the first 100 frames before the trigger. And then the 950 as well, it knows where to start saving those points. So I think we're good to go for the next drop. We'll press record here. Now we're in record mode. Let's see how this this plate drops. Oh boy. All right, another trigger. Okay, that's good.
Yeah.
That means my accuracy has been pretty spot on, because if I miss the accelerometer, it won't trigger. So.
Well, that's why we have multiple plates.
Yeah, we have multiple attempts going here.
Alrighty.
All right, so while this is saving, we'll do another a cleanup.
This will be maybe a little easier.
Less pieces, hopefully.
Less pieces.
We don't want to break any. We want to break it on
camera.
On camera, if possible.
I'm really good at breaking things off camera. Be careful. What? Put some gloves on. It's okay. I have tough hands. Cuts. I have calluses for a reason, people.
Oh boy. All right. So I think that's saved. Let's go into here, pull it out of our our saved location, and then open up this video data. Right here is the waveform save, and here is the video save, and then this project here, video data, as it's called, is the combination of the two. And then we'll make this full screen and come over here. So now we want to make sure that the video's on so we can watch it. So turn this video on. And now we can see the first frame it caught was as it's falling, as it's plummeting. And then we can play from here and see what happens. So we can see this red bar go through the timeline and see it'll approach and capture. So you can see as the time frame of the camera and the waveform response occur at the same time.
And we get to see how accurate Christian really was.
Oh boy. That's why I put it in the pad, make it bring out my, expand upon my target area. Let's see. Oh boy.
Oh man. It's flying.
Yeah. We can see, I saw a piece fly off in the direction of you, so we can see it. Oh, there it is.
You can use the video to help with, slow-mo video to help with cleanup.
Yeah,
Perfect.
yeah. So according to this trajectory, we should see pieces over. Let me see. Oh boy. Maybe I'll bring the on the plate, since the plate was white, it reflected the light a lot better than the other things we've been doing. Maybe I'll bring the exposure down for the next one, or the shutter speed. Oh boy. It's crazy how much can be captured in half a second.
Oh yeah.
There's 1,000 frames in half a second, and these pieces are like barely moving between frames. That's a weird sound. Let's make sure we're doing good over here.
Leave a comment if you liked the plate or the light bulb breaking
Oh, we got
better.
two. We got a nice and a looks solid. What's not solid anymore? It's
Yeah, the plate, not solid. Not too solid. Don't break those.
oh boy.
Don't drop those.
Oh, this is cool. You can see, so the plates have like a, I don't know, they were like fruit on them.
Yeah.
And in these
You
frames,
see the fruit pieces?
no, you can see the plate reflect the fruit from the, so the light is shining onto the plate, and then that was reflecting onto the ground, so you can see the fruit.
It's pretty cool.
But you can see the fruit pieces as it's rotating. Is that a peach right there? Oh boy. All right, how's cleanup look?
We're almost done. We're almost ready to reset, rearm.
That's pretty cool. All right, so we have more plates, but we also have cups, a vase,
I want to break a
piggy
cup.
bank. All right, I guess Courtney's got the cup. Let's see.
I don't know, this thing's a little thick. Curious to see if it'll break from a drop or if we might have to pull the hammer out on it.
All right. Let's close this. Yep, and go back to our original recording. Make sure we're looking good. Yep. All right. So, are you about ready to do your drop?
I'm ready.
Okay, let me check. Everything looks good. Okay. I think I'll get out of your way. Let you run the show.
Sweet. So we got this nice little Christmas cup here. It's very pretty. It's almost gonna be tough to break, but you know, this breaking it will be more fun. So I'm gonna go ahead and hit record. So we're recording now. All right, Christian, stand clear.
No boy.
Oh gosh, here we go. Should I run after him? Let's see. Oh, it didn't break! All right.
All
Did
right,
it
hold
trigger?
up. It did trigger,
It did
so
trigger,
it's
so we're gonna
good.
have to restart it.
We're gonna have to restart. Oh boy. See, I didn't have these problems. I've had 2 successful breaks.
I didn't want to slam it, you know.
You gotta drop it on its edge probably, because you dropped it on its heel where it's
All right.
sturdiest. I let this data save and then set up for the next one.
Cody says he likes the light bulb better. Unfortunately, we don't have another light bulb to break because I broke the light bulb prior to the live stream. The other one that we had. Sorry about that.
It was good. It let us know that we needed to bring out the hammer though, because the first light bulb broke, but the filament didn't break. I don't know what sturdy filament they were using, but we're like, okay, we only got 1 light bulb left to make sure it's a good break, so we
put the hammer down.
put the hammer down.
Yep.
All right. So
Is
I
it
think
rearmed?
drop
Ready?
it on
Drop
its
it here, like maybe
like that.
sideways.
A little bit sideways. See?
All right.
Hit the weak point. All right, I'll get out of your way again.
Here we go. Take 2. All right, we're recording. All right.
Oh!
I don't think I hit the accelerometer.
Wait. Oh boy. All right.
Oh no, it didn't trigger.
We
'cause
missed the.
I'm not accurate enough.
Yep.
It's okay, we have another cup. Maybe we'll let Christian try it.
Oh boy.
I guess I'm on cleaning duty again.
Let me stop that. Because it still recorded the data, even though there was no data to record, unfortunately. So we still gotta wait. Oh boy.
You can just see.
You know, we needed to aim for the.
You know, you can just see how I completely missed. I will admit that sports that involved hand-eye coordination have never been my thing. I hope you enjoy a little glass-breaking ASMR.
The beautiful noise of glass scraping the floor.
Yep.
Well.
Did it record anything? I'm guessing not.
Yeah,
Since
well,
it
it
didn't
captured
trigger.
it captures the after the fact because I had to trigger it afterwards just to make sure that it saved.
Oh, okay. Well,
right,
sorry everyone, that was a disappointment.
Well, it's a good thing we have 2 cups for you.
I know.
But this time, let's aim for the.
All right, that'll be good enough.
That's good.
We're gonna have a lot of glass to clean up. Sorry about your ears.
Yeah. Oh, one last piece. It was fun though. I got to go pick out things at like Goodwill and stuff that were like, oh, let's break this. All right.
I only got 1 more shot on the cup.
Yes. Are you ready to hit record?
Yeah, let's do it. All right, everyone, cheer me on in the comments, please. I need the assistance.
Yeah, let's make sure. Wait. Let's put the sensor in the best spot.
All right.
Hopefully you hit the same spot twice.
All right, here we go. Recording. All right, I got this.
Ooh.
That had to be it.
Yes. You nailed it. And sent shards everywhere. All right, and we'll
Much better. Thanks, guys. It's your comments that keep me going.
let's see. Cody said Stone Cold Steve Austin style. All right, this data's loading up. Start cleanup process again. I'm glad we have this tarp here because that is going to help with just all the tiny pieces that have been lost everywhere.
Definitely gonna need like a shop vac or something.
Yeah, we got stuff for true cleanup, but I don't think a shop vac would be very nice for the YouTube people to
Oh,
hear.
oh no, not right now.
All right, so
It's
there's
gonna be a job for you later.
yes. After this, when I say I'm working, but I'm cleaning my garage, does that still count as work?
I feel like it should.
All right, let's look at this most recent piece of data. Well, then I'm sorry to the team members that I'm gonna be busy for the rest of the day cleaning up this mess that Courtney's making. Oh, you really hit the accelerometer this time. You can see that you even have some reverberations from you hitting it.
Oh yeah, it was a perfect shot. Well, I guess we'll find out if it was a perfect shot.
All right, here it is.
All right.
All right, I'll clean so you can watch your work.
Some gloves. Oh.
Thank you for the gloves. Now your
Look at that athletic stance right there.
Full screen it so that
Oh, yeah.
they can see it in all its glory.
There it is. All right, here it goes. Oh, I hit it perfectly on that edge. Oh, I think that was a great shot. Oh, it just kind of crumbled. Oh, that's cool. It kind of crumbled and then glass started flying everywhere.
We should take these. We should talk with Kelly and see if we can put this into like I don't know, LinkedIn video or something.
Yeah.
Something cool, just clips of stuff breaking.
You know, I thought I moved out of this shot so fast, but my legs haven't moved at all.
Half
This
a
is only
second.
a half second.
Half
but,
a second.
I guess my reaction time is not as good as I thought it was. Oh yeah, that shiny glass just flying everywhere. Yeah, we're getting multiple small peaks here from the little glass pieces just constantly hitting the accelerometer.
Well, yeah, because you said it kind of crumbled, so
Yeah,
there's probably multiple hits on the accelerometer.
yeah. Sweet. Cameron said splash. Exactly. Oh, there we go. I'm starting to move out of the way now. All right. It's flying everywhere.
We can get your precise reaction time now.
All right, Christian, what do you want to do next?
All right. The vase, I don't know. The vase looks big.
I say the piggy bank.
The piggy bank?
Yeah.
All right. I guess the piggy bank. It's a Christmas piggy bank.
It's like a Mrs. Claus piggy bank. It's really cute. It's unfortunate it's getting broken.
I don't know if it's that charming there.
All right, comment if you think that the piggy bank's going to break first try. You're gonna have to put the hammer on it.
We'll
You're
have
gonna
to
put a
see.
little more force.
It's a little bit thicker.
Oh yeah, that's a thick boy right
Let's
there.
see. It sounds a little bit more dense. But piggy banks are supposed to break, right? That's the point of them?
I guess, but don't you usually break a piggy bank with a hammer?
I don't know. I didn't really have piggy banks, but
Oh.
we'll see. All right. Ready then?
Yeah, I'll let you do this one. I'm gonna move out the way.
Still, we can see there. Still good? Okay. All right. Let's see.
Oh. Ooh.
That was a thick thud. All right.
Oh, yeah.
Stop this. We
Yes,
should have filled it with coins or something. We could have had all the pennies spill out.
That's what I said, but Christian said he only has bills. He ain't got no change.
Bills is in things I need to pay. Ooh. Some more of this breaking. This one's nicer though. It's a little bit chunkier.
Yeah,
This
there's
came in
not as
chunks.
many small pieces to
Is this
pick up.
glass or is this like clay?
I think it's clay. I don't think it's glass. I don't know.
I think it's clay or something. It's weird. Here's the
Oh yeah,
dustpan.
much easier cleanup this time. Yeah, I got it. You
We're
go.
beating up this this manila folder now. Maybe we'll turn it around.
I hope it didn't mean anything to you.
All right, let's look at this analysis now. Come over here. Load this up. All right, we can see the trigger. Let's bring the video in. All right. Let's hit play. Oh boy, it's coming down.
Oh, it's falling so straight.
That's precision, Courtney.
That is precision.
This is only one attempt needed.
I hear you.
We got to live to our claim. We are the precision makers.
We are the precision makers, and Christian is clearly a better precision maker than me.
Oh.
At least when it comes to dropping things. I don't know about everything else. Wow, look at this waveform we got from the accelerometer.
Yeah. It just absorbed all that
Just
inertia,
like-
all the
Yeah.
all the inertia. It wasn't going anywhere, but it took all the weight. Oof. Oh, you can see it broke here and then up here. The whole top chunk stayed. It's crazy how even quick that it like breaks, because I mean, this is less than half a second. We're breaking up half a second into 1,000 frames, and you can see even the movement in one frame is pretty significant. So that's how fast gravity, like as it expanded onto the other parts, the acceleration transferred to the different pieces. That sounds like some physics stuff I had to learn back in college. Wow. Still,
Very nice.
It's still funny to see all these parts kind of like flying off and how they would like reflect the light as they're like spinning away.
Christian, you know what else we should have included in this?
What?
A thermocouple. Because as this garage gets hotter,
It is getting toasty. It is getting toasty. All right, we only got what, 2 more things left to explode?
I think we have water balloons and a watermelon. I think the watermelon's going to be the messiest, so I think we should do the water balloons.
Okay.
What do you think? Or do you want to do vase? What do you want to do?
I think we've
Any
seen enough
comments? Let's
glass
see.
breaking. Do we need to see a vase, or should we move?
We could do vase really quick, and then water balloon, and then watermelon. What do y'all
Okay.
think? Let us know. Let's know if you have a preferred order.
Look at the pig's butt at fly away. All right. So we're clean up from this. We can continue
Let's just
to
rearm
watch
it.
this,
Let's just
but-
go.
Oh, we can also speed this up a little bit. I forgot about that. There's some speed controls up here, so we can go a little bit faster. All right,
All right.
let's rearm. Okay, I think we're still good to go on the camera. Do you think brighter, darker? Should we make any adjustments to how much light's coming in?
Cameron said vase. Camo
Vase?
Simp said vase. Yeah, let's do the vase.
All right. You want to do it this time?
I'll do it.
We'll
I'll
give
do it.
you some
I
redemption.
need some redemption. I think this vase will break easier than the cup. Safety gloves, safety glasses. Recording is started. All right, we got this thick vase right here. I don't know, maybe not. This thing is pretty thick. I don't know if it'll break easier or not. All right, here we go. Aiming.
Ooh.
Woo!
Jeez, that, okay. I'm glad we're wearing safety glasses. That shard flew towards the wall. All right, and stop this.
Stop it, yeah.
Oh boy. That shattered pretty good.
That was a nice shatter. The glass is a lot to pick up. That watermelon, hopefully it doesn't explode past the tarp. We'll find out.
I think it's just gonna like crack and fall. I don't think it's gonna explode too much.
Well, depends on how much force you put on it.
Load up pull up this save file.
All right, after this vase, comment what your favorite break has been so far.
Loading up the project here. Bring in the video. All right, I'll let you watch your vase breaking.
All right, here we
Clean it up
go.
for you.
Did you say you could, oh, we can speed it up. We'll put the play speed a little bit faster.
Aw.
At least at the beginning.
Yeah,
Oh,
yeah.
Okay, all right. Is it playing? All right, it's going. All right, so you can see it falling. Oh, I don't know if it was dead center. All right, I'm gonna slow it back down to 1 speed. All right, here we go.
Oh.
Whoa.
It like shattered up and into the bottom. Where'd the dustpan go?
That's cool. It's right there. Oh, it just keeps breaking. All right, that one was pretty nice. That was a pretty cool one. We'll increase the speed again. Let's see if we can catch any flying pieces. Christian said he saw one fly pretty high up.
Kind of flew at the
Oh.
camera.
Oh, yeah.
But not- it
Yeah, you
flew-
can kind of see it. You can see a few pieces. Oh, yeah. The glass is actually really pretty.
It's funny, I even got the heavy duty tarp and it's cutting, the glass is all cutting up into it.
Sasha says it needs to be brighter on the breaking object so we can see it in HD.
All right, I'll turn up this light.
Cody says it's awesome to see the cracks spread through. Yeah, I think so too. Camo Simp said that was my grandma's manila folder.
All right, I think the light there should be good. Hopefully it's a little bit brighter than before.
Put it back. Put this back in the light. All right.
All right, water balloon time.
Water balloon time. At least that one's a little less dangerous, hopefully.
Yeah. All right.
All right, you go for it, Christian. I'm gonna move out the way.
Gonna do let's do a couple, right?
Yeah,
We filled
just-
up all these water balloons for a reason. All right, let's show off what one looks like. We just got
Without recording? Oh, yeah.
one
Oh,
of these
yeah,
bad boys.
yeah.
Water balloon, and then we'll hit.
Maybe it'll help cool us off.
Ooh. Hit record here. All right.
How many water balloons can you drop at the same time?
I think the answer is 6. All
All
right.
right, here we
Ready?
go. Oh, one didn't break. Oh, God. That was for the people.
Oh, now I'm wet. Maybe that wasn't the best decision.
Well, there's not as much cleaning up, but
Yeah, what do we do here? Do we just brush the water off the mat maybe?
I don't know. Maybe the water will help clean up the watermelon. Oh, geez. That one's going to be really fun to watch in slow-mo, I think. While we're waiting on this, Christian, what are some like common applications for this? Some real things some people would be doing.
Well,
with a high-speed
destructive testing is definitely common. It could be an application for this. Some things like vehicle collisions, stuff like that, you could see applications in. But also you can see just vibration testing. So seeing how something oscillates or moves. Typically, like in a car, you might want to look at different axles or different pieces of a motor, how it vibrates as it's going down the road. So highlighting something like that is definitely the application. And I mean, these high-speed cameras are very popular, and being able to just match whatever you're looking at with any kind of data, even if it's just an accelerometer or a strain gauge or temperature, not even electrical waveforms, being able to monitor those kind of waveforms in a scope quarter and synchronize them with a camera is definitely useful. All right, pull up the video, or the last capture. This project's loading up. Bring this in, turn on the video here. Oh, we can see there were 6 of them, so one of them's hiding back here, but let's go ahead and play it. We can increase this playback speed.
Oh wait, slow it down, slow it down.
Slow it down. All right. And then we can
All right,
see here.
which one didn't break?
I think it's this one right here.
Oh yeah. Oh no.
Oh no, it wasn't.
Where is the one that didn't break?
It was hiding. It's gonna come
That's
out.
so bright. Yeah, it's gonna bounce back at us. Oh, that water looks cool.
It's very exposed, so I think maybe it's too bright this time, but.
It's like that one water balloon's gonna emerge from the fire is what it looks like.
It seems like one of the, you remember those Capri Sun commercials where the water would just explode behind the drink? Yeah, that's what it, I think it's right here. Yep.
Oh, the water just keeps going. I mean,
Yeah.
I was way back behind it and I got splashed a little bit.
Wait, where is it? Is it here?
Yeah, I think it's there because, well, I don't know actually.
I think, well, there was 2. One popped a little bit afterwards.
Okay. Yeah, increase the speed a little bit.
Go a little bit faster.
Oh yeah, those water droplets look cool.
They're flying everywhere. It's like glass, but refreshing.
Yeah, not as painful. All right, which one's the survivor?
I think it's not this one. That's gonna pop. That's my guess.
Oh, no, I don't know.
Uh-oh, then it's a,
I don't know.
oh,
Oh no!
There's the time.
No! We should have set it up to record a little longer. I guess we'll never know.
Oh boy. We can look back in the live stream, I think. We'll be able to see, right?
That's true. We can figure it out.
All right.
Sweet. All right, last thing, right?
Last thing, yep. Coming in on an hour. We'll wrap things up.
Let's do it.
Get this watermelon exploded. Who wants, you want me to do it?
It's up to you.
This one sounds, let's give it a knock.
Yeah, show the people what we're working with.
Got a little watermelon here. Sounds good to eat right now because I'm sweating, but all right. We ready?
Do you want do you have like something you can put over yourself so you don't get all watermelon everywhere?
No, just this. Here, how about record from that side as well? Use that from back kind of where the cameras are. So we have just another angle for later.
All right, everyone, this is the finale.
Here we go. All right, I'm gonna put some force on it.
Will Christian get it first try?
It's recording, right? Yeah. Okay.
Oh!
That was a thud.
Oh man.
All right.
Well, let's tilt this camera. We can show you what happened a little bit better. Right?
Yeah, the other way. Hey. Oh. You're gonna give them.
All right, there we go.
There we go.
It's still kind of bright, but. Oh no, I just did.
I don't know. Maybe you took a picture or something.
There's our busted watermelon.
The remnants.
It kind of cracked. It didn't fully bust. Oh, but Christian's just gonna. All right. Oh.
Have a little bit of snack.
We'll snack for all that hard work.
Mm-hmm.
I'm gonna try to set this back up.
Here, I'm gonna turn it off so you don't give them a headache.
There we go. All right. I think you can turn it back on now. I think we're good.
I didn't get it off. Would you like some? Nice.
Yum.
All right.
All right, cool.
Let's get this data up.
All right, that one was fun.
All right.
Oh, I like that nice little slope down.
I think we capped off how high it can get.
Yeah.
Here's the video. All right. Come on. Speed it up just a tad. Oh man, this one's...
Oh, you can kind of see it. Oh, make it bigger.
Ooh.
Here we go.
Crunch.
The way it just sat down. It was not bouncing. Oh, but look, it got kind of flat.
Look at the juices coming out of it.
Yeah. Yum. That could be a watermelon commercial right there.
My fiance who's watching just said there was an apron in the laundry room. I think it's a little too late for that at this point.
Thanks, Sasha. Oh, that's cool. It like flattened out and then bounced back up.
Mm-hmm. It's kind of like a ball, but it exploded at the same time. That's funny. I put some heft into the chunk too, and it still didn't.
Not enough, it seems.
Not enough. All right.
Very cool. Well, that was fun.
Yeah.
I hope y'all liked watching that. That was fun for us to do anyway.
Yep. Let's see. Let me bring it back to our lovely faces. All right. you
Oh,
see? Are we
take
kind of
this.
tilted after Courtney reset us up?
Oh, I'm so sorry.
We're good. All right, well, I think this is a little bit different than the live streams we've done in the past, a little bit more fun, less technical, so we get to kind of show off some of the cool features that we don't necessarily do and get to show them off in ways that customers might not be able to. So if any of you have a DL950, I doubt that you've used it to explode water or to record watermelon and plates breaking, water balloons, all that stuff. So bring a little bit of fun to this.
Yeah, but now you know you can, if you sneak one out and just
Yeah.
have some fun home projects.
Yep. Well, the other thing is we have tutorials on how to synchronize this camera. So outside of this live stream, we have a different tutorial, different processes that's in our IS8000 training module. We also have training modules for the DL950 and for IS8000, and just kind of give you lots of resources to learn and to be supported without necessarily having to contact us. But of course, if you guys have any questions, there's yca-support@yokogawa.com or going to the tmi.yokogawa.com website to contact us, and we'd be more than happy to support you. Hopefully it's for something cool like this, but not sure.
But any questions you have, we're here. We've got a team of AEs, application engineers that are here to help, and any questions you have, let us know.
Yep. And lastly, we want to thank Motion Engineering Company for lending us this camera. If you guys have any projects like this, you can go to highspeedimaging.com and get in contact with them to rent one of these cameras for your own setup. But hopefully in total this was a fun live stream, and hopefully we get to do a couple more like these going forward. All right, well, if that's it, I think we'll sign off.
Thanks everyone for joining.
Bye.
Bye.
Ooh.